Welcome back. In this one, we're talking about pseudocode. So, AP Computer Science Principles is programming language agnostic, which means the course can be taught using any programming language. As simply put, the College Board doesn't dictate what language this course should be taught in. The idea is that they wanted to basically open it up. They thought that if they kind of made it a little bit more generic, that more teachers, more schools would start teaching computer science, and so then computer science could reach effectively more people. That's the idea as to why it is programming language agnostic. Now, I have chosen Java as the language here because the follow up course, AP Computer Science A, is also in Java. And so I kind of view it as we're going to get a leg up on the competition, if you will, that students that go through my curriculum would have already had some Java experience. And so we can get in a little bit deeper or basically have more experience under our belt. So what this actually means is you won't see Java code on the AP Computer Science Principles exam. Instead, right, there's one exam and it doesn't matter what language. Instead, what you're going to see are code-based questions written in something known as pseudocode. Pseudocode is an informal programming language intended for human reading rather than machine reading. So the syntax that we're going to look at, it's not formal. It's not formalized, meaning you're supposed to be able to kind of like handwrite it. So think about like a rough draft for an essay. The idea is that whenever you're kind of developing some code, you would maybe kind of jot some ideas down in something that looks like code, that is quick, easy to read. You're not worried about semicolons, that sort of thing. Okay? So you don't have to be able to write pseudocode. You just need to be able to kind of read it. And so when we're looking at this syntax, it is syntax. This is syntax that the AP, the College Board, has developed, but it's loose. Don't take it as literal law, right? If we're programming in Java and you forget a semicolon, nothing works. That's not necessarily the case here, right? That's not meant to be the case. Pseudocode attempts to make programming languages easier to understand by omitting non-essential details, particularly those for humans. Additionally, pseudocode is meant to be a universal programming language. Ideally, code written in pseudocode can be easily translated into a conventional programming language such as Java. So diving right in, here is variable declaration and assignment. Okay, our syntax is going to be, you'll have your variable on the left-hand side, and then we have this guy. This is going to be our assignment operator, and you're saving this thing into this variable. Examples of this include 7 being saved into X, hey being saved into str. Okay, so I quite like this little arrow. It is a replacement for the Java assignment operator, but I like that it shows direction, right? It's showing that we are saving 7 into X. Whereas this, I think, us being from the Western world, kind of read this from left to right, but that's not the flow. That's not the direction in which things are being saved into. Now, right away, you should notice that pseudocode is dynamically typed as opposed to statically typed. What do I mean? These variables over here, they don't have a data type, right? In Java, this is a statically typed language. Whenever we're declaring our variables, we have to preemptively say what data type should go in it. And we're restricted to that once we do that, right? Integer x. X is being declared as an integer, allowing us to save integers into it, but that's all we can save into x from that point on. That's not necessarily the same with dynamically typed. And there are dynamically typed languages in the world. I've been working a lot with JavaScript, for instance. Python is another popular one. And they have their pros and cons. You go through this, you get used to this, you actually start to like it. I personally prefer statically typed because it helps clean things up a little bit later. It helps with readability from a programmer standpoint. Dynamically typed, in theory, you can save anything into this. That also means that the data could change over time, meaning even though I'm putting 7 into X, X could later store a string, for instance. That is something that happens with dynamically typed languages. So it's very important with dynamically typed languages that you make very meaningful variable names. X and str, probably not very meaningful, although str at least kind of to me indicates that I'm saving a string in and expect it to stay a string. Additionally, I'd like you to notice that there is no semicolons here, right? No punctuation is required to mark the end of a pseudocode statement. Instead, each line of pseudocode is a single statement. Again, this is loose. If it's meant for humans, right? As a human, I can tell that this is one statement just per line, whereas a compiler cares about these semicolons. That's how it marks that, so that it knows when and where to stop, that sort of thing. Despite their syntax differences, these things are going to function effectively the same, other than the dynamically typed nature here, where we could, in theory, change what type of data is over time. So it's a variable. Initially, you see I'm saving 7 in, but because it's dynamically typed, we don't really care what gets saved in. So we go from an integer, effectively, to a string, and then back to an integer. What's important here is that the value can change over time. It's just a variable. I'm over explaining this. It's just not that level of complicated. The result of arithmetic expression could be saved into the variable, just like in Java. Right here I have 3 plus 4. That's going to give me a value of 7. So ultimately I'm saving 7 into x. And then here we're going to print it. And then you should notice that we have display here. Display is going to be how we effectively print. Right, this is replacing our SOP. Right, in Java, we would do systemout.print in order to print off a 7. Here, we can use display in pseudocode. Okay, input. What's the replacement for that? Like, what is the Java equivalent? That is going to be our equivalent to our Java scanner stuff. We're just getting some type of input. Again, we don't care about the data type. It could be a string. It could be an integer. Here I'm saying it's an integer, but it could be anything. We're just getting input, saving it into a variable, right? So what I'd like you to kind of recognize here is even though we kind of have a programming language here with pseudocode, it's not like I can go get an IDE, right? There's no IntelliJ for pseudocode. So really what this input really means is like generic input. We expect the user to input something. It's an unknown to us, but it's going to be saved in X, and then in theory you would work with that for the rest of your program. Here's our arithmetic operators, and everything's the same, except we get down here to our mod, right? In pseudocode it's written out. The word is written out. I praised pseudocode for the arrow because it showed direction. I'm gonna deduct some points here because just use the % sign. Every language I know of uses the % sign here, which, by the way, I might have touched on this, but there's a division bar. That's why they use the % sign, is because it's division, right? It has the same level of precedence as division. I wish they just would have went with the % sign. Pseudocode, I kind of like this. Right? The equivalent to not equals is what you're used to in math. Same thing down here. We're used to these symbols in math. In Java, we can't do that. But in our pseudocode, are effectively a handwritten programming language. You can do what you want. And all these make sense to me. So I'm happy with those. These are okay. I mean, these symbols are kind of confusing, right? I mean, vertical bars meaning or, it's kind of silly. I mean, once you learn it, it's just like, oh, yeah, sure, whatever. But on first occurrence, this is a little bit weird. So the words I kind of like. In some languages, Python, I believe, they actually do this, right? It's not symbols, it's words, and the words are the actual action. So I'm okay with this. We have if statements. And these are going to function just like what you're used to in Java. We have if some condition. So this is going to be a Boolean expression, which means you're going to need logical operators or you're going to need relational operators. But if that expression is true, we would enter the body of the if statement and execute that, right? So here, I'm going to get some input from the user. And if that input does not equal 42, I'm going to print off not 42. Okay, that if can be an if else. An example of that is we're going to get some input from the user, and we'll say if that user input is greater than or equal to 0, we'll say that it's a positive number or 0. Otherwise, it must be a negative number. So that's effectively it. I'm going to give you some questions on this, an exam prep, and yeah, I think you can take it from there. I'll see you in the next one.